Hi everyone, I'm here again to do another domain and range problem. This will give you two examples of how to solve these problems. Do this one in blue this time. Okay, so now we're looking at a function. Now in this function, although the arrows aren't listed, notice that these two functions will extend forever in both directions. And in fact, these functions will extend forever in both directions, up and down, and left and right. So our domain and range are going to be really easy this time because I can pick any x value and somewhere it will appear on this graph. And you can also see that by looking at the original function. If you look at this function y equals x to the third plus 2x squared minus x, you can put in any value for x and somewhere it will appear on the graph. Even if I take 5,000, somewhere it will appear on the graph. So what that means is my domain for this one is all real numbers. Another way to write that in interval notation is negative infinity to positive infinity. And whenever we use infinity, we always use parentheses, not brackets, because infinity is not an actual number, but a concept. And notice that our range in this case is exactly the same, because it extends up and down forever as well. Left and right, up and down forever. Okay, so that part was pretty easy. Now, for the intervals, what I always like to do is first let's find the intervals and then we'll go ahead and figure out if they're increasing and decreasing this time. So here's one interval here. There's one interval that goes from all the way to the left and then comes up and approaches this point right here. Okay? And this point looks like it's about negative 1.5. I don't know exactly what it is, but I'm going to estimate it at negative 1.5. When you get into calculus next year, we'll actually look for exact values. But in this case, let's just estimate for now. And then there's another interval that runs from there to here. Okay, and this looks like it runs till about 0.25 because each of these increments are 0.5. It's about half that, so I'm going to say it's about 0.25. Okay, so what happens now, and that's our second interval. And then our third interval runs from 0.25 all the way to infinity. Okay, so let's write these up. Again, remember it's like you're on a roller coaster and you're starting on the very left-hand side. So on the very left-hand side, I'm going to start at negative infinity, and I'm going to ride my roller coaster until I get to negative 1.5. All right, and then my second interval, I'm going to ride down here. I'm going to write down this one until I get to, so I'm going to start at negative 1.5, and I'm going to write down until I get to 0.25. And then my final interval is from 0.25 to positive infinity. So let's go back and review what happens here. In the first segment, I'm going to switch to a different color even to show this. So in my first segment, I go from negative infinity until I get to 1.5, okay, going from left to right. All of that is increasing, okay, increasing, because I'm going up the roller coaster. Then when I get to that top point at negative 1.5, I'm going to go down the roller coaster until I get to 0.25. So that is a decreasing part of the function, okay? And finally, in the last segment, I go from 0.25 all the way up to, or all the way to the right to infinity, and I'm increasing. Okay. So basically, we've completed the assignment. Now, if you really want to think about this in terms of what you're going to look at for next year, we're going to learn more about these critical points. And the critical points are the ones that aren't labeled here. And that's this point here at negative 1.5 and this point here at 0.25. Both of these points are critical because what happens is it's a point at where the roller coaster is level. Okay, you're not increasing or decreasing, you're constant. And so for the optional piece, if you wanted to write it, what you would do is you'd say at negative 1.5, closed brackets, I'm constant. Okay? And also that is true of 0.25. I'm also constant. So at those moments in time, those exact moments in time of being on the x value, I'm constant. So at the very top, right, at the very top of the roller coaster, and also at the very bottom of the roller coaster, at that moment in time. I'm not going to say the very bottom. Well, actually, because the very bottom is way down here, right, where we started. But at that moment in time, your roller coaster is level, it's constant. Again, I'm going to star these. I'm going to star these in red to know that you don't have to do this yet. It's an extra level of learning. The part that we really want to know is all the blue here. So we want to know the domain and range, and we want to know what are the intervals where it's increasing, decreasing over the entire length of the function. Okay, I hope that helps you to understand this function better. Thank you.